Axis interpretation is a relatively confusing topic, but once you simplify it, you will get the importance of this. Axis interpretation is based on the QRS complex. The major vector of the ventricle's direction of spread is mapped out as the QRS complex. And understanding the deflections of this will help determine if the overall direction of the electrical activity is in the normal direction or not. There are several approaches to estimating the QRS axis. The quadrant method involves lead 1 and AVF. The 3-lead analysis uses lead 1, lead 2, and AVF. And the third method is known as the isoelectric method. Now, all of these demonstrate the relationship between the QRS axis and the frontal leads of the ECG. Lead 1, if we recall, is part of the Einthoven triangle, going horizontally from negative to positive. And AVF provides an inferior view, starting from the positive electrode below going towards the negative. Let's illustrate this on a circle. If lead 1 goes horizontally, then the two hemispheres can be made, with the right side as positive QRS and the left side as negative. Same way for the AVF, since it's an inferior view, looking from the positive pole, the bottom half will be positive and the upper half will be considered negative. Now, if we combine these two, we create 4 quadrants and overlap in the lower right. This lower right quadrant is known as the normal axis. So in order to get a normal axis of the QRS complex, in lead 1, you would need a positive QRS. Positive as in the overall deflection between the R wave and the S wave is predominantly upward. Plus, you would also need a positive QRS in the AVF lead. And this would also mean between the R wave and the S wave there's a predominantly positive deflection. Now that we've established the normal axis, what about the significance of the other quadrants? Keeping in mind the indications of lead 1 and AVF on the cycle, the normal quadrant's overall vector is in the same direction as the heart's conduction pathway. It's not entirely 90 degrees straight, but tilted at an angle since the left ventricle is thicker, and so the average vector points in favor of that. Let's say the right ventricle becomes hypertrophied. Then the average electrode vector will swing towards the right. This in relation to lead 1 and AVF is that lead 1 will have a negative deflection of QRS and lead AVF will have a positive deflection. When we say negative deflection, the QRS is predominantly downward. This is called the right axis deviation and is associated mainly with conditions that put strain on the right side of the heart and could be both conduction or structural related. The opposite can also occur. Let's say there's a major conduction defect on the left branch or the left ventricle, and that gets super hypertrophied. The average vector will then deflect towards the left side. In such a case, the lead 1 will have a positive QRS and the AVF will have a negative QRS. This is known as left axis deviation, and the most common reason is usually due to a conduction defect. Think about it. To have a vector deflect at this angle, the anatomical structure here would be the left bundle branches, and so a block in the LBB can result in this type of QRS deviation. So in this circle, we have the normal quadrant, a left deviation, and a right deviation. And this upper left quadrant is known as the extreme axis deviation. It has a lot of other names like northwest or intermediate axis, but this type of deviation is very, very rare. Let's discuss the other topics of axis interpretation methods. I'm going to combine the third lead and the isoelectric analysis methods. The term isoelectric here is misleading. It's more indicative of an equiphasic lead. As we learned earlier, a positive deflection is predominantly upwards, a negative deflection is predominantly downwards. But equiphasic means that the upward and downward deflections are both equal, as in R is equal to the S wave. The 3 leads are based on lead 1, lead 2, and AVF. We already know lead 1 and AVF's orientation. What about lead 2? Lead 2 is parallel to the heart's conduction pathway. Let's look at the area lead 2 influences on the circle. As the conduction pathway follows the potential traveling from negative to positive, The positive half ends up being towards the bottom left. Now when we merge all of these hemispheres together, we can see that the normal axis falls between a different range to the previous circle we discussed. The normal axis is in between negative 30 degrees to positive 90 degrees. The right axis deviation is from 90 degrees to 180 degrees, and the left axis deviation is the remaining quadrant of the upper right. The extreme axis deviation is still the same quadrant from the previous circle. So this is just a matter of range, and when QRS deviations are questionable, clinical symptoms will be more helpful in making a definitive diagnosis. Let's map the frontal leads out to have a better understanding. The bipolar leads are mapped out with the lead 1 going horizontally, lead 2 and lead 3 with an inferior view. The unipolar leads have AVF going vertically, AVL and AVR coming in from either sides. These limb lids are present in the coordinate system and facilitates ECG interpretation. So how do we use this? So when you look at an ECG strip, first spot the equiphasic lead. Then make note of the QRS directions and the 3 leads. Are they positive or negative? And the last step is to calculate the QRS axis. The QRS axis of the equiphasic lead should be 90 degrees towards the direction of the positive lead. So let's try out an example to understand this better. In this strip, the first thing we need to find is the equiphasic lead, which in this case is lead 2, as its R and S wave is equal. Next step is to note the deflections of the other leads. Lead 1 is pointing downwards, so it's negative, and AVF is pointing upwards, which is positive. So the final step says that the QRS axis of the equiphasic lead, which in this case is lead 2, should be 90 degrees towards the direction of the positive lead, which is AVF. So in this diagram, lead 2 is right here, and it has to point toward the positive AVF in 90 degrees, which brings us to the area where we labeled as right axis deviation. So this strip is indicative of a right axis deviation. There are a lot of causes as to why right axis deviation can occur, and in this one, it's a normal variation. This finding is normal in a tall or thin person. Unfortunately, there are a lot of minor variations in ECG, which are consistent with perfectly normal hearts. And so it is important to know the limitations of using QRS deviation. That being said, the next time you see a cardiac circle like this, you will know how to interpret it. And that's the end of today's video. Thank you for watching.